All right, so happy start of second semester. You should have picked up the homework packet and the note packet when you came in. So we'll be on the note packet to start, and then we will hopefully get to the homework packet and at least go over a couple of problems today. Remember, today's only a 2-mod day, so we're only in here until 35. Okay, let's do this. So if you could do right now on page 2 of your note packet, the retrieval, if you could do numbers 1, let's do 1 and 2. You guys quick do 1 and 2, and I'll do number 3. How's that sound? Okay? All right, do 1 and 2 quick for me. In number 1, does A work? Is it a solution? No? How come? This would be 5 equals -4 times -4 plus 5, right? Which is so that's going to be positive 16 plus 5, which is 21, and is 21 equal to 5? No, so that doesn't work. So that one is a no-go. What about B? Did B work? -4 times -2 is positive 8. Positive 8 plus 5 is 13, right? 13 is equal to 13. Yep, so that one works. What about C? Because that one has a slope it's in slope intercept form with a y-intercept of 5. And that's got a y-intercept of -4, so that one's a no-go. Yep, we don't even have to do that math. D. Does D work? Yeah? Yeah. I think D works. -3 equals -4 times 2 plus 5. That's going to be -8 plus 5, which is going to be -3. -3 equals -3. Yep. E. Does E work? Yeah. Okay. -11 equals, it should be a -4 times 4 plus 5. Excuse me. That's going to be -16 plus 5, which is -11. -11 is -11. Yep. So B, D, and E were the ones that work. Okay. Find a missing value that will make each ordered pair a solution to the given equation. So if I plug in 0 for x, what happens to any part of that equation with an x in it? It goes away, right? It just because so the 2x goes away, right? So then 2x, if 2x goes away, then that's just 0 plus y, and that's just y. So y has to be 12. So that would have to be 12 there. In part B, what are we doing? Placing the y with 0, right? Okay. So then that would be 2 times x plus 0, I don't have to write it, equals 12. So x has to be 6. Yep. Those two are special, right? Why are they special? They're intercepts, yep. The top one, this is the y-intercept because x is 0. The bottom one is the x-intercept because y is 0. Okay? Those are special. Okay? So we have to remember that those are what those are. Okay? Quickly on the next one, so then that's going to be -2 plus y equals 12, so that's going to be 14. 2 times 5 is 10. So that's going to be 2. And 2x plus 6, which would be an x, is 12. 2x is 6. X is 3. Okay? I really wanted to focus in on A and B there, because those are the intercepts for that one. Okay? Love it. Let's jump ahead here. Okay? So, let's take it back to those intercepts again. Find me in this equation, because they both work out nice and neat. Find me the x-intercept, and find me the y-intercept. Okay? Find me the x-intercept and find me the y-intercept just in number 1. Go for it. So for the x-intercept, that's where y is 0. So this would be 2x is less than 20, right? So then that would be x. Actually, hold on. I forgot to tell you one thing. For intercepts, we got to be equals. So we're going to go equals here. So x would equal 10. So the x-intercept would be 10, comma 0. Do we agree with that for the x-intercept of that one? Okay. Set y equal to 0. X-intercept is where y equals 0. Y-intercept is where x equals 0. So for the x-intercept, we're going to leave x, but y is going to become 0. So 0 times anything is 0. Okay? Okay, kind of like what we were just doing, right? With those on those first two on the find me the ordered pairs. Okay? Y-intercept, now x is 0, so that 2x is going to go away. So we're just going to have 4y equals 20. So y is going to equal 5. So that's going to be 0, comma 5, right? What do you mean you left it in? Oh, okay. I see what you're doing. I gotcha. Except you forget you went with x is 1 instead of x is 0. Yeah. Yeah. Kind of same thing. If you would have put in 0, would have plugged in 0 there instead of 1. Yeah. Mm-hmm. You found me the 1 intercept, not the like the x and the y intercept. You know what I mean? Yeah. Which is fine. Okay. Now, where we're getting to, okay, the reason why I did this a little differently is because where we're getting to is we're getting to a spot where if I connect these two, and that's going to give me a line, right? Only takes 2 points to make a line. Yeah. 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 Why did I make my line dashed? No, discrete would be dots. No. No. It is exactly because of the inequality. Because it doesn't have the equals part of the inequality, right? Okay? So that's why I made it dashed. Okay? Now, it said find at least 5 pairs that make that this inequality be true. Well, anything down here would make that inequality be true. Okay? So as long as my point is in that shaded region, it would be true. So like one point that would make it true would be the origin. right? Because the origin's right here, and that's in my shaded region. If I plug in my origin, 0 is 0, 0 is 0, 0 plus 0 is 0, 0 is less than 20. Works out. Okay? Another point that would work would be like -5, comma 0. We get -10 is less than 20. And so on and so forth. That's where we're getting to. It's going to take us a little bit of a roundabout way to get there, but that we're getting to. So if we want to find true parts to make these inequalities, we can just graph them, find the area that works, and then go with that one. You go with any point that's in that region. If I were to pick a point not inside that region, let's say there's the point 10, comma 5, right? 10 over, 5 up, so I know that it's right there. If I plug that point in, this would give me 20. This would give me 20. And 20 plus 20 is 40, right? Is 40 less than 20? No, so that doesn't work out. So that's why that doesn't, we don't shade on that side of that line. Okay? All right, let's jump to Carlos and Clarita. They're, as you can, if you can recall, back in the first part of chapter 5, which was before break, we met up with Carlos and Clarita, and they were going to groom, or board, excuse me, not groom, they were not a grooming service, they were a boarding service. They were going to board dogs and cats, okay? And so we want to find at least 2 more combinations of cats and dogs for too big and not too big, and find the 4 that work, but tap the brakes. Let's just go right into it. Okay? So let's take this part right here. Okay? And let's make an inequality out of it. Okay? So Carlos and Clarita plan to invest much of the $1,280 they earned from their last business venture to purchase cat pens and dog runs. It costs $32 for each cat pen and $80 for each dog run. Okay? So first thing I need to know is I need to know some variables. What variables should we use? C for cats. D for dogs. Love it. Love it. Keep it easy. Love it. So C is the number of cats, D is the number of dogs. Okay? Love it. Let's go back and make an inequality now. How much money do they have total that they can invest? 1,280. So I'm going to start with 1,280. And now I'm going to wait. I'm going to pause here for a second. I'm going to go to the other side. Okay? Okay? It's going to cost $32 for each cat. So how would I write that in my inequality? 32 what? 32C. Yep, exactly. If you went with X and Y, that's fine. Just make sure that you wrote down that X is cats, Y is dogs. Yep. It's going to cost $80 for each dog. How would I write that in there? 80D. What am I going to do with 32C and 80D? I'm going to add them together. Okay? So now we got 2 sides, right? Which side has to be bigger? It's going to be the bigger side? The 1,280, right? Because the 1,280 is the amount of money that they have to spend, and they can't spend more than that. Correct? Okay? Do we want to have so the alligator is going to eat the 1,280? Yeah? Okay? So it's going to look like that. Yes? Okay, now let's jump down here to our graph. Okay? We just said right? Yeah. Okay. So find me the cat intercept, meaning where there's 0 dogs. The cat intercept would be where there's 0 dogs, right? So how am I going to find the cat intercept? What am I going to plug in? And where? If I want to find the cat intercept.
Wait.
What am I going to plug in? So what? So I would plug in 0 for D, right? Because remember, so like I'm trying to relate this back to x and y intercepts, right? So when we had the x-intercept, what was true? Y was 0, right? So if I have the cat-intercept, what's true? Dogs is 0, right? Okay? So if I have a cat-intercept, then dogs is 0. So 1,280 is going to equal 32c plus 80 times 0. Well, 80 times 0 is just 0. So what is 1,280 divided by 32? What you got? 40? Yep. So they could board 40 cats and 0 dogs. With me? Okay. Find me now the dog intercept. How much? 31? I think 31's too many. Yeah, 31's way too many. How much? 16. So they could also board 16 dogs and no cats. And still be under budget. Or still, well, they would be at budget. Okay? So, how far can we go up by 20? 1, 2, 3, 4, 5. 1, 2, 3, 4. Perfect. We can go by twos. Okay? So 2, 4, 6, 8, 12, 14, 16, 20, 22. Oops. Not 22. Okay? So if we go by twos on our scale, so our cat intercept would be way over there, and our dog intercept would be up there, and we can connect those with a... Would we have to go with less than here, our inequality? or could they spend? They could spend it all. So we could have the equals part. Okay, so we could have the equals part here. So that means what changes with my line then? Instead of it being dashed, now it's just solid, right? Just regular old, yep. So if they want to spend under that amount of money, they would spend in there, right? Or that would be a spot that they would. So if they had, now let's check it to make sure. If they had 20 cats, and 6 dogs. That would be somewhere right in about there. Okay? Should work, right? When we plug it in. Okay? Somebody with a calculator is going to need to help me out. 32 times 20. 640. 80 times 6. 480. 480 plus 640. 1,120. Is that less than 1,280? Boom, we found one that worked. Okay. Now, the nice part is now you can go back and answer all those questions. Spots that they spend too much money would be over here. So these would be the too much spent area. Down here would be they came in under budget. And points that are right on the line they spent exactly the right amount of money. Okay. A little easier than just trying to guess and check, right? Okay. Being able to just go right to it, and then we just got to interpret what we have. Okay. Good times. I think that was it for there. One thing that I want to remember or remind you of is the 3 different forms of a line. Now, we really have only explored 2 of them. Okay? The slope-intercept form of the line is everybody's favorite. Y equals mx plus b. Okay? It makes it easy to solve for. Okay? B is the y-intercept. Go to that point, put a dot. M is the slope. Rise over run to get the next one, the next one, the next one. Draw your line. Okay? Point slope form, we taught it to you as y equals y sub 1 plus m times x minus x sub 1. where you have the point x sub 1 comma y sub 1. Standard form is a little different. Standard form is x and y are on the same side, and the numbers are just on the other side. As you get higher and higher in math, then standard form will come with more and more conditions. Okay? No fractions, no decimals. A's got to be positive. Okay? For right now, we're just getting to, we just want, if it's standard form, we just want x and y on the same side. Okay? Linear inequalities, no equals part, then it's dashed. Equals part, it can be solid. Okay? Love it. Quick peek at your homework now. Now, I know this is in the other packet now. Just a quick go through in the last 2 minutes here of class. Okay? 1 through 3. I just want to know if those points work or not. You know what I mean? Plug in those points. Show me if they work. Tell me if they work or not. Yay or nay. Circle the ones that work. Okay? 4, 5, and 6 are find the missing ones. So x equals 2 for the first for A's. Then you're finding the y-intercepts for the B's. Then you're finding the x-intercepts for the C's. Okay? Hold on, I'm not done yet. I got a whole minute yet. Okay? 7, 8, 9, and 10 are all graphing. 11 and 12 graphing. Now here in 13 and 14, it's asking you to find that shaded spot. Okay? So we like to call it a test point. So you pick a point and you test it out. Kind of like what we did when we said 20 cats and 6 dogs. We picked a point and we tested it. If it's true, you shade it. If it works, if it makes the inequality work, you shade on that side. If it's not, shade on the other side. Okay? Thanks for playing along. Have a great day.